In the last episode, we discovered why Wi-Fi can pass through walls while visible light cannot. But today, we're going to answer another question you've probably noticed every day. Why does your Wi-Fi become weaker as you move farther away? Does the transmitter lose power? Or is something else happening? Let's find out. Imagine standing right beside your Wi-Fi router. Web pages appear instantly. Videos play without buffering. Now walk into the next room. The signal isn't quite as strong. Go upstairs, and it becomes weaker still. The same thing happens with Bluetooth earbuds, mobile phones, FM radio, and even GPS signals from satellites thousands of kilometers above Earth. No matter what kind of wireless technology we're using, the signal always gets weaker as the distance increases. So, why does this happen? Many people imagine that the transmitter is gradually running out of energy, as if it were getting tired the farther the signal travels. But that's not what's happening. The transmitter is radiating exactly the same amount of power the entire time. The signal isn't losing power because the transmitter is producing less. Instead, the same energy is simply being spread over a larger and larger area as it travels outward. And that simple idea turns out to explain one of the most fundamental laws of wireless communication. Imagine holding your hand close to a garden hose. Almost every drop of water lands on your palm now. Step farther away. The hose is still delivering exactly the same amount of water every second. But the water spreads over a much larger area. Only a small fraction reaches your hand. Nothing has disappeared. The water has simply spread out. Radio waves behave the same way. A Wi-Fi router, Bluetooth device, or radio transmitter doesn't gradually lose power. It keeps transmitting the same amount of energy. But as the waves travel outward, they spread in all directions. Each square meter receives less energy than the one before. That's why the signal becomes weaker with distance. Not because the transmitter is producing less, but because the same energy is spread over a larger and larger area. But there's one important difference. Water from a garden hose mostly travels in one direction. Radio waves don't. Without directional antenna, they spread outward in almost every direction. Now imagine an invisible sphere surrounding the antenna. As the waves travel farther away, that sphere keeps growing larger and larger. The transmitter hasn't become weaker. It's still producing exactly the same amount of power. But now that same energy must be shared across an ever-expanding surface. Every time the sphere grows, each square meter receives a smaller share of the total energy. The farther the wave travels, the more thinly that energy is spread. Engineers have a name for this. It's called power density. The amount of electromagnetic power arriving on each square meter of space. And as distance increases, power density steadily decreases. Here's where things become truly fascinating. Suppose you move twice as far away from the transmitter. Most people would expect the signal to become half as strong. But that's not what nature does. Instead, the signal becomes only 1/4 as strong. Now move 3 times farther away, and the signal falls to just 1/9 of its original strength. Go 4 times farther, and only 1/16 remains. The signal weakens much faster than most people imagine. This remarkable pattern is called the inverse square law. Why does it happen? Because radio waves don't travel through space like water flowing through a pipe. They spread outward in every direction. As they travel farther from the antenna, they cover the surface of an ever-growing invisible sphere. The radius of that sphere increases linearly, but its surface area grows with the square of the distance. So, every time the distance increases, the same amount of transmitted energy must be shared across a much larger area. No energy has disappeared. It has simply been spread much more thinly. And that's why wireless signals become weaker so quickly as you move farther from the transmitter. Once you understand this principle, you'll start noticing it everywhere. Walk away from your Wi-Fi router, and the signal gradually becomes weaker. Drive farther from a radio station, and the broadcast slowly begins to fade. Take a few steps away from your phone, and your Bluetooth connection becomes less reliable. Different technologies, the same physics. As electromagnetic waves spread farther from their source, their energy is distributed over a larger and larger area. That means less energy reaches your device and less reaches you. This is also why distance plays such an important role in RF safety. In many everyday situations, simply moving farther away can dramatically reduce your exposure without changing the transmitter at all. Sometimes, the simplest solution is just a little more distance. Here's something many people find surprising. A wireless signal doesn't suddenly disappear. It simply becomes weaker and weaker as you move farther away. Eventually, the signal drops below the sensitivity of your receiver. At that point, your phone, Wi-Fi adapter, or radio can no longer separate the signal from the background noise. The transmitter hasn't stopped. The radio waves are still there, traveling through space just as before. But by the time they reach your receiver, their energy is simply too weak to be detected reliably. To the receiver, it's as if the signal has vanished. In reality, it never disappeared at all. Today, we've discovered that wireless signals don't become weaker because they lose energy. They become weaker because the same energy is spread across a larger and larger area. This simple idea, known as the inverse square law, is one of the fundamental principles behind wireless communication. It explains how Wi-Fi, Bluetooth, mobile networks, GPS, and countless other wireless technologies behave. Once you understand this principle, you'll never look at a wireless signal the same way again. If wireless signals naturally become weaker with distance, how can satellites communicate from 36,000 kilometers away? How can signals travel across space and still be strong enough to receive? The answer lies in one of the greatest inventions in wireless engineering, the antenna. And that's exactly what we'll explore in the next episode.